All right. Hey, class. Welcome back to BUS352. I am Dr. Danju. Today we're going to be covering chapters 4, probability. What is the chance? What is the likelihood of something actually happening? What we're going to do today is we're going to do a quick lesson. Then we're going to knock out the homework assignment. Probability throughout the remaining of this class, we will be using that over and over and over again. So once you get this concept, it should help you with the rest of our chapters to come. All right, we will be using probability, the chance, the likelihood of something actually happening. So far, we have defined a thing, basically in chapters 1. Chapters 2, we collected, organized, and visualized something. Chapters 3, we started to get into the analysis, the descriptive statistic. Now we get to go even more into the analysis and find the probability, the chance, the likelihood of something actually happening. So what I'm going to do is I'm going to share my screen with you all. And once again, my head is going to be on a swivel. Bear with me. All right, we're going to get through this. All right, so hopefully you can see my screen. Perfect. Right. And let's get into this topic of probability. All right. Once again, it is the chance, the likelihood that an event will occur. Please understand probability in your mind's eye. You should see it as a decimal value. Most times we think of probability as a percentage, but in this class, I want you to think not of the percentage times 100. I want you to think of a decimal value, a number between zero, let me find it, 0 and 1. All right, the chance, the likelihood. So if you were to have these dices, all right, what is the probability that, let's say for one of them, you're going to get a 2? Or what's the probability that you're going to get a 6 or a 3? What is the chance, the likelihood that you're going to actually get that thing? All right, so let's get into this lesson for today. From my Christian worldview perspective, I want to ask a tough question. What is the probability that what God is saying is actually true? Hmm. Many times, we hear that whatever God says is 100% true. But can we actually test it to see if it's true or not? Today, in my example, I'm going to be using these two persons. This guy is going to represent Abraham, and she's going to represent Sarah, his wife. So here's my question to you. From a high level perspective, what is the probability that a 90 plus year old couple will have a child? Hmm. All right. What is the probability that they can actually have a child? Here, Abraham is 75 years old and he has no kids, and God makes a promise to him. What is the probability that at 75, his wife is about 65 or a little older? All right. What is the probability that they can actually give birth or have an actual child? Well, this is where the story picks up. In Genesis 12, 1 through 4, the Lord said to Abraham, go from your Abraham, he didn't change to Abraham until later. Anyways, he says, go from your country, your people, your father's household to a land I will show you. I will make you into a great nation. Wait a minute. How can you make me into a great nation? I'm old and I got no kids. What are you saying? All right. And I will bless you. Do you believe what God is saying as true? Or is there a chance, a likelihood that it's not true? God is speaking to him and says, I'm going to bless you. I will bless you. I'm going to make you into a great nation. So kids are coming. I will make your name great and you will be a blessing. Now, as you're hearing this story about Abram, I want you to think and put yourself in his shoes, just where you're at right now. Could God be saying to you, I'm going to make you into a great nation? Could God be saying to you that I'm going to bless you? Could God be saying that I'm going to make your name great and you will be a blessing? The more you know. All right. But God goes on to say to Abram, I will bless those who bless you, and whoever curses you, I will curse. And all people on the earth will be blessed through you. Now, could it be that God got your back? And people who hook you up, God is going to hook them up. And people who curse you and put you down, God is going to take care of them. Hmm. The more you know, this is what God was saying to Abraham. So Abraham went as the Lord had told him. He believed, and Lot went with him, his little nephew. Abraham was 75 years old when he set out from Haran. Guys, you got to understand that the way God works is a process. He tells you something. It could happen instantaneously or it could take some time. Basically, when Abraham was almost about 100 years old, this promise came to pass. It takes a time. All right. In the meanwhile, Sarah was like, there's no way that this is going to happen for me. I'm going to be blessed with a child. So what she did was she's like, hey, Abraham, here is my concubine. Take her. Maybe this is what God is talking about. Take her and make a child with her. And maybe that's what God is talking about. Now, fellas, if your wife says to you, here's another chick you could have, would you take it or not? Listen, don't say nothing. Don't answer it. Answer it in your brain. All right. But some of you guys are like, yeah. Some of you guys are like, no, that. Anyways, Abraham went ahead and had the concubine, had a child, but God was like, nah, that's not what I was talking about. You're going to have a child with Sarah. All right. So over 90 years old, she was able to give birth to a son, this promise, this great nation that God had promised him. What is the probability that God, whatever God is saying is true or not? We can actually test it. But note to self, whatever God says is 100% true. It will come to pass. All right. But if it's not what God is saying, it will not come to pass. In business statistics, we say that we can calculate probabilities. All right. If it's not going to happen, they say it is quite unlikely to happen if it's at zero. If it's at 1 or 100%, they say it is almost certain to happen. But in business statistics, they realize that there's a force that can change the impossible to possible and the possible to impossible. This is why they say almost certain, because they know there's a hand that could change what is 100% to not be 100% and what is quite unlikely to make it quite likely. God ultimately has control. But when we're dealing with probability, it is the chance, the likelihood. Even though we calculate it to be this high, it might not be. There's a possibility that things could still change. It is the chance, it is the likelihood. All right. So as we go through this probability and understand the concept of probability, it is the chance, the likelihood of something actually happening. All right. So let's get into our lesson for today. All right. We're going to learn all of this stuff right here, but we're trying to make this the most effective and efficient way possible. We're going to understand probabilities, all right, as best as we can, and then jump into the homework assignment. So let's get into this. All right. When we're dealing with probabilities, we're dealing with some kind of uncertainty. Right, good, good, good. Remember, probability is between 0 and 1. It is a decimal value. Good, good, good. On the exam, they're going to ask you this very same question right here. The range of probability or probability is between what two numbers? 0 and 1. Yeah, yeah, don't mess this up. Get this right. Once we get into the homework, we'll make sure that we have this ratified or checked correctly. Good, good, good. All right. So when we're dealing with probabilities, we're dealing with some kind of experiment, some kind of test. All right. And we're checking to see Is it what it's saying that it is, or is it not? Or what is the percentage, or what is the probability that something will actually happen? All right. There's three probabilities that we're going to actually be checking: the classical method, the relative frequency method, and the subjective method. All right. The classical method. If we're dealing with something like a die, all right, a dice have six different um, possibilities. All right, one, two, three, four, five, six. How do we calculate the probability? It's 1/6. So whatever your total sample size is, the probability is 1 over that sample size. That is the classical method. The relative frequency method is what we've been doing. All we're doing is we're finding whatever frequency that is, that small value. All right. So for example, at zero, that frequency is 2 divided by the total. That will be your probability. We've been doing probabilities, all right? You might not have known it was probability, but all it is that small number divided by your bigger number, your x divided by your n, and that is your probability. So we can find the probability for each one of these. Please note that all of your probabilities must add up to 1 or 100%. Yes? All right, good, good. That's the relative frequency. The subjective method is based on your opinions or someone's opinions. What is the probability that a 90-year-old couple can actually get a baby? All right. Most people will probably say less than 1%. All right. But if God says it, it's 100%. You see how that works? All right. But it is subjective. It's based on someone's opinion, whether right or wrong, that is their opinion. So, I mean, you can't change it, right? That is the subjective method. But what we're going to be doing in this class is these two, the classical method or the relative frequency method. All right. So when we're dealing with some kind of experiments, we got to make sure that our experiments have well-defined outcomes. All right. So with a coin, it's well and defined. It's either going to be heads or tail. All right. If you're inspecting a part, rolling a die, playing a football game, it's either a win, a loss, or a tie. It is well defined. All right. Good, good, good. So I got some examples in there. I'm not actually going to go over this. Actually, let me go over this one so you guys can actually see the classical method, and then you can understand the relative frequency method. All right. Church members who attended church during the week are as follows. What is the probability on a given day 50 members will show up to church during that week? So here's your data, right? How many times does 50 show up? All right. Hopefully you can eyeball this and see that they show up 3 times. What is the total number of days? 6. So it is 3 divided by 6. But because we're dealing with probability of 50, we put P for probability and we try to make in parentheses a brief description that describes what we're talking about, like precisely. So all they did was a probability of 50. Yeah, yeah. If they wanted to do the probability of 40, it will be P in parentheses 40. You see how that works? All right. And if they were to do 40, 40 shows up 2 times, it will be 2 divided by 6. Yeah, yeah. All right, good, good, good. So once you got that concept, that's the classical method. What are they talking about? How many times does that thing show up? Divided by the sample size, the total. All right, good, good, good. Now, let's get into the relative frequency method. What is the probability that candy will be selected? All right. So when you have your frequencies, you must always, always get your totals. So we can just assume that the total is 26. All right. So you guys can calculate just to make sure. All right. But let's say all of these were 26. What is the probability that candy would be selected? Do you see candy is 5, the frequency is 5. So all it would be is 5 divided by 26. But watch how we would do it. The probability of candy, you see, equals to 5 divided by 26. So what happens if I were to say, what is the probability of milk? Yeah, it will be 7 divided by 26. You will put the probability and then in parentheses, milk, and then 7 divided by 26. Hopefully you got this concept. All right, let's keep this thing rolling. Now, the way we actually write this is probability is between um, 0 and 1. Yeah, yeah. All right. And all of your probabilities must add up to 1 or 100%. Good. All right. We're going to show you how there's different rule ways to find probabilities in terms of if you want to find the actual totals. All right. Total outcomes. We're going to show you this permutation formula right here in Excel once we get into the homework. All right. And factorial. Some of you guys know what a factorial is. So if you want to know the factorial of 5, it's 5 times 4 times 3 times 2 times 1. That is the factorial of 5. All right. So we got that. We're going to show you how to do this one. But this is the part that I really want to get into. All right. We're going to be putting things in order in a contingency table. And in that contingency table, can we calculate the probabilities? We're going to take regular numbers, convert them into decimal values. Once we convert them into decimal values, then we can answer and figure out what is the joint probabilities. Where do they actually join? All right. The joint probabilities are inside of your data. All right. They're not the totals. They're actually your data points. All right. And for me, in my mind, so I could mentally see this, all right, is where does, for example, B1 and A1 connect? A more better way of saying, where do they actually kiss? All right. Where do they actually join together? All right. So here is your first point. All right. Where does B1 and A2 connect? Right here. Now, these are your joint probabilities. When you get to the totals are your actual probabilities. Yeah, yeah. So what is the probability of B1? This plus this will give you the probability of B1. Hmm. What's the probability of B2? This plus this will give you the probability. These are your marginal or simple probabilities. Yeah, yeah. How do you find the probability of A2? This plus this will give you the probability of A2. All right. So now that you kind of get the concept, once again, this is not going to make sense until you actually get into the homework, but just flow with me for this and for right now. So in general, we'll do some kind of survey, some kind of poll, and get regular numbers. Let's say we were to do a poll on, does your car have AC or does your car have GPS? All right. And these are the numbers. Let's say, for AC and GPS, 20% says, yeah, man, my car got AC and GPS. I'm rolling. All right. We will take then these regular numbers. Here are your joint probabilities. All right. And then here are your totals, your marginal probabilities. Yeah, yeah. You see how that works? But we must take these numbers and convert them into probability values, into decimal values. What am I saying? We'll convert them into these numbers right here. So how does 20 give you 0.2? All they did was that 20 divided by 100. Whatever your total is, your total for both sides, you'll take that divided by 100. That's how they got zero point 0.2. So once we have this, what is the probability that you will have a GPS? It is the total of your GPS, zero point 0.4. Hopefully you're seeing that. What is the probability that you will have an AC in your car based on this poll? 0.7, 70%. Hopefully you can see that. All right, so I'm going to show you now how to figure out these calculations, whether they're in union, whether it's an intersect, mutually exclusive, and hopefully this makes sense to you all. All right, a complement of an event. How do you actually calculate the probability of a complement of an event? All right, so the probability of A plus the probability of A's complement equals to 1. What does that mean? Let me kind of break this down to you. All right. So let's say you had the probability of GPS is zero point 0.4. It's all of GPSs. You add these two up, and that's how you get zero point 0.4. All right. The complement of GPS is no GPS. Hopefully that makes sense. So when you add up these two, they must equal to 1. Hopefully that locks in. All right. So the complement is everything else but that thing. All right. So let's say AC. All right. Let's say AC represents the probability of A. Instead of A, we're going to replace that A with AC. All right. AC's complement, AC's complement will be no AC. Hopefully you can visualize this. When you add up these two, they equal to 1. Yeah, yeah. All right. Let's go on to it. Union A in union with B. How do we calculate A in union with B? Here is your formula. It is the probability of A plus the probability of B minus where they intersect. This is how we write intersections, where they actually connect. These are your joint probabilities, where they actually kiss. All right. So here, let me see. Let me grab, um, I want to grab my pen, but I want to type as well. Um, I don't want to try to, uh, let me see. Will it allow me to type something on here? Pen, ink. No. Okay, so I don't see it on here, but the way this works is, all right, I guess I'm gonna have to draw. Bear with me on this. All right, grab a pen. All right, so let's say the probability of A, let's say this is, we're gonna say the probability of A is, we're gonna be dealing with the probability of AC. All right, so I'm gonna put the probability of AC plus the probability and of B, we got to go the opposite side. Let's say we make that B GPS. All right, so I'm going to make this, it's hard to write with the mouse, so just bear with me. GPS minus where they intersect, the probability of AC and GPS. All right, that's close enough. All right. So ultimately, we've replaced those A's and B's, those are placeholders, with actual things within our data set, AC or no AC, whatever. All right. So we have our actual numbers right here. So the probability of AC, right, is all of AC, zero point 0.7. So this number right here, this whole thing right here will be 0.7 plus, sorry to be messing this up, the probability of GPS. It's all of GPS. Do you see how this 0 0.4, 0.4 minus where do they intersect? Where do they actually kiss? All right, 0.2. And that is the probability of A in union with B. Zero point 0.7 plus zero point 0.4, hopefully in your mind's eye, you're thinking 0.11, minus zero point 0.02, which is 0.9. So all of this will be equal to 0.9. Yeah, yeah. If you have that concept, I think you'll be able to understand what is going on with probabilities. All right. So when they say the probability of A, it is all of A. When they say the probability of B, it's all of B. When they say the probability of C, or where they intersect, is where they actually connect, join together, or kiss. All right. Good, good, good. So I'm going to keep this thing pushing. All right. Remember, where they intersect is where they actually kiss, join together. Good, good, good. Last but not least, mutually exclusive. Here's your formula. The probability of A in union with B when things are mutually exclusive, they don't connect, they don't join together, they never kiss. No longer. So if someone comes to you and say, hey, look, we are mutually exclusive, it means, look, we're no longer connected. We're no longer kissing. I'm making sense. All right. So when we're dealing with probabilities, if something is said to be mutually exclusive, that part where they connect does not exist. It equals to zero. Yeah, yeah. So all the formula is the probability of all of A plus the probability of all of B. So if we had AC and GPS, it will be zero point 0.7 plus zero point 0.4. Yeah, yeah. When they're mutually exclusive, they never connect. The more you know. All right. So with that said, I'm gonna get rid of this. All right, let me get back my laser. Let's go through this, keep going. We've provided you guys tons of examples in this PowerPoint, but I want to wrap it up with this last part right here. How do you calculate conditional probabilities? Here is your formula. All right. The probability of A slash B. When you see that forward slash, that straight up and down slash, it means conditional probability. All it is saying is where do they intersect? Where do they actually kiss? Divided by whichever probability comes last. Do you see it? Do you see it? All right. So give me my penmanship again. Bear with me on this. All right, I'm going to grab this. All right, so let's say the probability of A, we're going to replace A with AC again, and we're going to put slash, and we're going to put B, we're going to replace B. Let me make that A a little bit better. All right, and what we're going to make that B, GPS, just like we did before, right? G, P, and A. That's a beautiful P. Leave me alone. GPS. What is the probability of AC and GPS? Where does AC and GPS intersect? Zero point 0.2. So this one right here will be equals to 0.2 divided by what is the probability of what comes last? GPS comes last, which is this one right here. What is the probability of GPS? It is all of GPS, all of it. So divided by 0.0, and that will be the conditional probability of AC slash GPS. Too easy? Hopefully it makes sense. Hopefully you can visualize it with your eyes and get this done correctly. All right. How do we do the multiplication law? It looks like this. The probability of A and B. All right. For the multiplication law, is the probability of all of B divided by the conditional probability of A and B. All right, we're not going to get into all of that, but we're going to show you how to set this up in Excel. Independence, all right, how do you know if something is independent or not? If the conditional probability of A and B equals to the probability of A, you would say that it's independent. If the conditional probability of B slash A, do you see A come last? Then, and it's equal to the probability of whatever comes first, then it will be considered independent. Multiplication law looks like this for independence, A and B, where they intersect. If you multiply the probability of A and the probability of B, and these two are equal, then it is independent. Last but not least, Bayes' theorem. Yeah. Fortunately for us, we're not going to go into all of this, but if you break it down into pieces, you could be like, oh, I could do this. The probability of A, all right, all of whatever A you're dealing with, plus the conditional probability of A slash B, yeah, yeah, divided by the probability of A, conditional probability, blah, 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 and so on and so forth. All right. This is just to show you what it actually looks like. But what we're going to do is jump into the homework assignment, knock these out, and show you how to find probabilities. All right. Let's get into it. If you guys can, please go into Cengage. Where's my Cengage at? It's one of these. Oh, way down yonder. All right, good. Go into Halo. All right. We're going to grab, first of all, the Excel template. You can go to the Trello board. In the description below, you'll see the link to the Trello board. All right, go to the Trello board. I'm going to go right here. All right. And what we're doing is we're looking for chapters 1 through 4 Excel templates. Scroll down until you see chapters 4. Click on this up arrow. Download your Excel file, please. Download your Excel file. I've already have mine downloaded. All right. Enable it, download it, and enable it. So let me grab my Excel file. Give me a second. Where we at? This is chapters 4. Good, good, good. All right, I have it right here. Once you have it, please save it. You will need this for the exam. So go File, Save As. All right, and I'm going to save it to my desktop. And once again, hopefully you have a file on your desktop. All right, so I'm going to go to my desktop. All right, if you do not have a BUS352 folder, please create a new folder. Call it BUS352. All right. Go into that folder and paste your Excel file there. Save it. All right. Gimme, gimme. It's nice and saved. You will need this for the exam. So please make sure that you're using your Excel templates. All right. So now that we have that, we're going to start off with 4.03. But please, if you can, go into Cengage, go into Halo. All right. If you go to week 3, all right, you should be able to see wherever your chapters 4 is. Click on it and open assignment. All right. So I'm going to grab it. All right. So once you have it, then you can do a dual screen. All right. So while this is loading, I'm going to slide this over to the left on my end. All right. I'm going to get my Excel to the right, and I'm going to multitask. All right. Please multitask on your end. All right. Cengage might be slow, but hey, be patient with it. Excel might be slow. Be patient with it. And let's get through this. So we're going to start off with 4.03. So click through until you see 4.03. All right. I'm going to find it right here. Perfect. All right. So you got different letters, and they want what is the possible outcome if you had 6 different groups and 3 items. All right. So up here, just type in A, B, C, A. I want to make them all caps. That's for my OCD. D, E, and F. All right. So the number of items, we all should have 3. Good. The number of groups is 6. What are your possible outcomes? This is where we use the permutation law or rule. All right. Here is your formula. Remember, it was factorials. All right. In Excel, it is fact. So highlight, copy it, Control C, Command C, double click, and paste your formula over to the right. All right. So capital N, if you double click on capital N, it highlights capital N. Grab your capital N's number. Double click on N, grab it. Double click on lowercase n and grab it, please. All right, press enter. Bam. Check your work. Make sure you're good. Yep. All right. And once again, for these drop downs, just get the right answers. All right. I didn't even read all of this, but just get the right answers, check your work, and keep this thing pushing. All right. So just get the right answer and roll. All right. So if you want to put a section in here just for that, all right. List each of the permutations of items. All right. You can put list. And you can type in B, D, F, blah, blah, blah. Whatever works for you, just fill it out, make it do what it do for you. All right, for me, I like to align right. You see, I'll put that list over there. I can yellowfy this. All right, I'm not gonna yellowfy it because I don't want my system to basically crash out because I'm dealing with Zoom and Excel and Cengage. I'm not gonna mess with that. All right, so we have that. Let's go on to 4.06, please. Actually, I thought I saw that somewhere up yonder. Yep, 4.06. All right. And an experiment with three outcomes has been repeated 50 times. So how many outcomes? All right, three, and the total 50. Yeah, yeah. All right. So then it goes on to say E1, 2020. E2, please plug in your numbers. Each of us is going to have different numbers. All right. And then this is 16. All right. How do you find the total? Always, always get your total. All right. A quick and easy way to do this, you'll see this big E symbol right here. If you click it, it will give you the total. Or you can type in what you see on the screen, equals to the sum of B4 colon B6. All right, press enter. Always, always get your total. All right, good, good, good. So now the question is, and once again, um, we're basically doing the relative frequency method right here. All right. They want to know what is the probability of E1. So here's your formula. I'm going to grab it, copy it, Control C, Command C. I'm going to double click and paste. Double click on E1 and grab your E1's number. Double click on the total, grab the total's number, and we're going to make this total static. Dollar, dollar. Dollar sign in front of the B, dollar sign right after the B. And as soon as you see dollar, dollar, you should know in your mind's eye that you can pull this down. All right, so I'm going to go to the bottom right and drag it down. Yes, yes. All right, so we can plug in each of those probabilities. Hopefully you're like, man, this is too easy. Yes. Once you know what you're doing, it makes it easy. If you don't know what you're doing, it's a struggle. All right. So good. And then which method did we use? All right. Hopefully you're saying it's the relative frequency method. Yeah. All right. We take that small number divided by the bigger number, your X divided by your N, and that's how you get your probability. All right. Good work. Good work. Good work. So I'm just going to put RFM. All right. Good work. All right, let's go to 4.009. This is an exam question, so we got to make sure that we get this one right. All right. The range of probability. Probability is between what, two numbers? Hopefully you're saying 0 and 1. All right. So you can check that box if you're a Windows user, or you can redify this. Once again, I'm not going to click it because I don't want my stuff to just freeze out and I can't do anything else. All right. So find it. It's between 0 and 1. Check your work. Make sure you're good. Yes, sir. Good work. All right, let's go to 4.15, please. 4.15. All right. This one is dealing with a deck of cards. All right, so let me go through where we at? 4.15. Bam. All right. So consider an experiment of selecting a playing card from a deck of 52 cards. All right. And the deck of cards is 52. All right. Um, how do you actually find this sample point? It's basically 1 over 52. So you put equals to 1 divided by this. Some of you guys, this is going to show up as a date. Please change it to a general number. All right. But we really don't need this. So if you want to calculate this, you can. If you don't want to calculate it, that's fine as well. All right. So I'm going to get my decimal value right here. All right. But make sure that it's changed to a general number if yours shows up as a date. All right. Good, good, good. So then it goes on to say, how many sample points are there in the event that a king? So in mine, I'm dealing with kings. A king. All right. How many kings, all right, in a deck of cards? All right. Some of you guys might say there's 4 kings in a deck of cards. All right. Even if you don't know, just check your work. Yes, indeed. All right. So I will put down 4. All right. Good, good, good. How many sample points are there in the event that a spades is selected? Type in spades. All right. How many spades in a deck of cards? All right. Even if you don't know, all right. You plug in a number. All right. You think it's 13, plug it in. Good, good, good. Let's go. All right. How many sample points are there in the event that there's a non-face card? All right. So there's 52 cards. How many non-face cards? All right. So in my case, I have non-face cards. Good. Non-face cards right in the problem itself. Do you see where it says non-face cards? Some of you guys may have face cards. So if there's 40 non-face cards, isn't there 12 face cards? Yeah, yeah. All right. So whichever number you get, please adjust the sentence accordingly. All right. But for mine, it's going to be non-face cards. So I'm going to type in 40. All right. So now that I have that, I can change this as well accordingly. You got to make your templates do what it do for you, your problem, your situation that you're dealing with. So mine, instead of Jack, is going to be King. Instead of spades, oh, it's going to be spades and it's going to be non-face card. So adjust your Excel accordingly. All right. So now, how do I find out for kings? All right. Find the probability associated with each of the events in parts A, B, and C. Round your answers to 2 decimal places. All right. So this will be simple. Equals to, we'll take this number divided by this number. All right. Your smaller number divided by your bigger number and gimme, gimme. All right. And we're going to select all 3 of these. Go in the middle of the cell, select all 3. And we're going to change these to 2 decimal places. Bam, 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 bam. So the rest of these are going to be set to 2 decimal places. Trick and tip, the more you know. All right. How do you find spades equals to? Click it divided by the total. Yep, yep. This one right here equals to click it divided by the total. A. All right, press enter. All right, you should be able to type in those numbers and you should be able to get your answers. Check your work. Yes, indeed. All right. So hopefully you see how that concept work. All right, we're using the relative frequency. If we're dealing with a deck of cards, if we're dealing with just regular numbers, we take the small number divided by the bigger number, and that is our probability. Yeah, yeah. All right. Let's move on to 4.29, please. 4.29. Find it, find it, find it. All right. 30, 31, 29. Perfect. All right, so we got a whole bunch of reading right here. And like I said before, if you have problems with word problems, always look where the numbers start and start from that sentence. All right, so I can see right here, suppose that a recent admission class, an Ivy League college, received this amount of applications, all right, for early admissions. So I'm going to put in 2851. And please be reminded that we all have the same numbers and answers on this one. So just follow along. I'm just going to put rejected, good, deferred. Hold on. All right, so rejected was, give me a second, let me make sure I got, early was that. It admitted, all right, so I don't need admitted. I got rejected, 854. I got deferred, 964. All right. All right, I guess the total is 1,033. All right, and this is 18%. All right, good, good, good. Let me see, what all do I need on this? We got that, we got that, we got that. All right, so let's go to work. Let's see how this calculation is going to work. I'm going to grab this formula, copy and paste to the right, double click on my E, grab my E's value, double click on my N, and grab it. All right, something don't seem right. Give me a second. Um, let's see what is happening here. Total applications. Let me see. Give me a second. Of this group, admitted. Oh, okay, okay. I see what I did. All right. So just swap these numbers right here for 1033, and this number should be 2851. All right, good. Yes, that makes much better sense. Let me make sure that is right. Sorry, I'm just rushing through this. I didn't get to read all of it, but all right, good, good, good. Now we got it right. So because I'm going to always be using this total, I'm going to make C4 static. Dollar sign in front of that C, dollar sign right after that C. All right, and then I could drag it down. All right. And they want 4 decimal places for all of those. Good. 81. Good. And I'm going to check my work. Outstanding. All right. Are events E and D mutually exclusive? All right. Events E and D. When you're early admitted and when you're deferred, do you actually connect? All right. So in my case, I would say yes, they are mutually exclusive. They never connect. So you can put up in this piece, yes. All right. Then it goes on to say, find the probability of E and D. E and D. All right. If they're mutually exclusive, E and D never happens. So E and D would be 0. All right. If they never connect, all right, then that is not happening. Check your work just to make sure. Perfect. All right. Then they give you a new sample size. What happens if your sample size was 2,375? A, type it in right. We're going to use this calculation right here. Copy it. We're going to paste it. Double click on E, grab E's number. Double click on N, grab your new N's number. Press enter. All right. 4 decimal places. Check your work. Make sure you're good. Outstanding. All right, last but not least, suppose a student applies for early admission. What's the probability that the student will be admitted for early admissions? All right, here is your formula. But one of the things that you need to understand is formulas within Excel do not have spaces. So we're going to get rid of these spaces. We're going to highlight and copy all of this, Control C, Command C, paste it in there. Got to double click. All right, we're going to double click on all of the probability of E. All right, all of the probability of E, this first one is what we need. So we're going to click it. Then we're going to click on all of this, the probability of admitted regular applicants. All right, which one is that? The probability of admitted regular. Okay, this guy right here. We're going to click it. And then times the probability of D, deferred. We're going to click it. So just keep this one simple. B9 plus B6 times B11. All right. Once you press enter, all right. You hold your breath and hope you did it right. If we did it right, we should check our work and be able to see ding, 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 green. Outstanding. All right. So if for some reason you missed any one of those, go back into the video, stop it, and you'll actually see how I did each part. All right. Three more to go. Let's wrap this up. Let's go to 4.30, please. I believe this one is on your exam. So please make sure that as we go through these final couple right here, that we get those right. All right. So yes, 4.30, it says, suppose that we have two events, A and B. All right, with the probability of A, please plug in your number. All right, good, good, good. And the probability of B, plug in your number. Good. And where do they connect? Where do they actually, you know what I'm saying? Anyway, it's point two. Good, good, good. How do you find the conditional probability? Here is your formula. We'll grab it, copy it, and paste it. We're going to select all of this. Where do they actually intersect, join together? All right, we're going to click it. And then we're going to say the probability of B. Click it. And that will be your conditional probability. Bam, point four. All right, good, good, good. Check your work, make sure you're good. Yes, indeed. All right. Then what they did in parts B is they flipped the switch. Instead of the probability of A slash B, now they're doing the probability of B slash A. All right, they flipped it around. Well, it's too easy. We can still get this. We're going to grab the formula, copy it, paste it, highlight all of this, and click it. Highlight all of A, and click it. Bam. And they want this set to 4 decimal places. So I would select all of these and set it to 4 decimal places. Move it over. All right, just please make sure you set these to 4 decimal places. All right. Check your work. Outstanding. All right. So now the second part right here, we just get these right. But we want to understand why these are right, because this is going to be an exam question. You got to make sure that you're checking to see if they're right. All right. So ultimately, what you're looking at is this conditional probability and A. Are these two numbers equal? All right. So I'm just going to put a note, equal, equal. As I can see, point 4 and point 6, they are not equal. On your end, are these two numbers equal? If they're equal, then you would say, are A and B independent? Why or not? Why not? I would say no. The conditional probability is not equal to the probability of A. So let's check our work just to make sure we got the wordings right, because sometimes Cengage twists stuff around. Good. So I will put no, is not. On the exam, your head is going to need to be on a swivel. All right. If it's equal, then it is yes, it is. If it's not equal, so I will put equal, is, or yes and is, not equal. I will put no and is not. All right. And just for me, I'm going to align right. I'm going to make this a note to myself. Yeah, yeah. All right. Now, if I wasn't on Zoom, I would have yellowified these. All right. You see that yellow fill? You could do it on your end. All right. Just so I would know, hey, are these two numbers equal? Yeah, yeah. If they're equal, then it is independent. If they're not equal, then it is not independent. All right. Let's go. Two more. 4.31. Mhm. All right, so you just plug in all the stuff that you have, the probability of A, gimme, gimme, probability of B, gimme, gimme. All right, and then it goes on to say, assume that we have two events, A and B, that are mutually exclusive. They never hook up, they never kiss, they never join together. All right, good, good, good. So what is the probability of A and B? Zero. What is the probability of the conditional probability if they never connect? How can they connect? All right, there's no conditions. All right, zero. Check your work just to make sure. Good. So we're just going to type in zero, zero. All right. And then it goes on to here. All right. Just get these right. All right. These are drop-down answers. I'm not going to answer it for you, but just get it right. This is not going to be an exam question. Once you get it right, just fill these out. All right, correctly. All right, good. Let's go to the last one, 4.56. This is an exam question, so I want to spend more time on this. So let me scroll up. All right. You're going to have different numbers. I'm going to make this just a tad bit smaller so I can see it all. Your job is to type in all of those numbers, please. All right. So I don't know if you can do a row at a time. Copy. Let me see. Single click and paste. Nope. All right. So this is where you want to just manually type it in. All right. So I'm just going to type in that. I'm just going to go downwards. Manually type it in. Don't mess this up. Pay attention to what your tendencies are. If you like see 500 and you put 400, make a note to self. So on the exam, when you're typing these out, you can type it in correctly. Double check. All right. And one more. All right, so I'm gonna maximize this so you guys can actually see this. I'm gonna zoom in. Yeah, it's too much. Right there is good enough. All right, on this side, remember, we have to take these regular values and convert them into decimal values. All right, how do you do that? So in here, just put equals to, click on that first one, divided by that very last total right here. Click it. All right, we're gonna make F6 static. Click right before the F, make it dollar sign. Right after the F, dollar sign. Now you should know you can pull it down and then drag it over. So I'm gonna pull it, drag it down. Yeah, we made those decimals and we're gonna drag these over. All right, hopefully you're seeing that. And for me, I like to make these two decimal places. All right. Now, typically, I would make this green. Why? Because I don't want you guys to be messing with this on the exam. All right. So how do you make it green? I would select this and greenify it. All right. So please make it green. I'm not going to do it right now because once again, I'm still on Zoom and I don't want this thing to crash out. All right. So once you have your answers, let's go to work. Here is your formula for the first one. Copy, paste. Good. Second one, copy, paste. Third one, copy, paste. Fourth one, copy, paste. Bam. All right. Now let's go and see how Cengage wants these decimal values set up. First one, two decimal places. Second one, three decimal place. Fourth one, four decimal place. A. All right. And then this fifth one, two decimal place. Please make sure you set up your decimal places correctly. And let's plug these in. Check your work, make sure you're good. Yes, indeed. And are events A and B independent? I didn't really look or I didn't check, but once again, it's a drop down. Please make sure you select it. All right, so in my case, it's going to be no. Check your work. Yes, indeed. Please type in here no. All right, that will be it for that. All right, but once again, if I were you up here, I would greenify all of this. All right, greenify it. All right, so what I'm going to do is I'm going to stop sharing. I hope you get the concept of probability. Every time we're dealing with probability, it's the chance, the likelihood. God ultimately has the final say. Whatever God says is true. All right. But when we're calculating probability, it is the chance, the likelihood of something actually happening. Remember, every time we're trying to describe probability, we put P for probability and then in parentheses, whatever specifically we're trying to cover. So, hopefully you get this concept. If not, please go back into the video, see how we did each individual part. Look down in the description below to find the link to the Trello board, and you should be good to go. All right, next up is we're going to prepare for this exam, and your goal is to get 100%. So watch the video on the exam review, and let's get that 100. Have a great day. Thanks.